Welcome to today's class, Process Synchronization. Today I am going to handle what is process synchronization and why it is needed, critical section problem, Peterson solution, synchronization, hardware. So here several processes run in operating system. Many of the processes access the same resources at a time. So because of this reason, data inconsistency may arise. So here consider these two examples. So in the first example, the two processes, process A and the process B. So here the process A changing the data in the memory location, where process B wants to access the data from the same memory location. So it is possible to the data accessed by the process B will be incorrect. Okay, that means the data inconsistency may occur in this type of example. So let us see that another example, again the process A and process B. Here the process A updates the x value is equals to 2. At one point of execution of the process A, the process B updates the x value is equals to 3. Now based on the execution of the instructions, the final results is depends on the order of execution of the instructions. So here this condition is called the race condition. So race condition is nothing but when multiple processes access the same data item. Here the data item is x. So here the result is depends on the order of execution of the instructions. So here to protect against this race condition, we have to provide the process synchronization. So what exactly mean by the process synchronization means when the two processes are there, the only one process can manipulate the data at a time. So that process synchronization is required. So this is what called that these two examples, based on these two examples we can understand what is process synchronization and why it is needed. Now coming to the critical section problem. Generally, critical section problem means we can consider the segment of code common to that n cooperating processes. That means the several processes can access the same data variables from this segment of code. This segment of code is called the critical section. Coming to this critical section concept, if the one process is in that critical section, it is possible we should not allow that other process to execute that variables in that particular critical section. So here when any process wants to enter into that critical section, it must take the permission to enter into that critical section. There is a critical section environment is there. In the critical section environment, it's having entry section, critical section, exit section and reminder section. So here the entry section means code requesting to enter into the critical section. We already know that what is critical section. The critical section is a code. It allows the only one process to execute the code in that critical section. The exit section means end of this critical section. It's allowing or releasing the processes. The reminder section means the rest of the code of the critical section. This is that when one process wants to enter into that critical section, it must take that permission to enter into the critical section. To solve this critical section problem, there are three requirements are there. Those three requirements to solve the critical section problem, the one is that mutual exclusion. mutual exclusion, and the second one is progress, and third one is bounded waiting. Right. Coming to the mutual exclusion, suppose if you consider the process PI, if the process PI is in the critical section, we should not allow any other process to execute in that critical section. Coming to that progress, suppose if there is no process in the critical section, other process wants to enter into that critical section, then only that the particular process is not in that reminder section, we can allow that particular process to enter into that critical section. That is what the another requirement, progress. And the next one is bounded waiting. The bounded waiting means there exists a limit. That means if the one process, how many times it should allow to enter into that critical section by the other processes when it requests that to enter into that critical section before granting that request. That is the bounded waiting. When we satisfy these three requirements, it solves the critical section problem. Then coming to the another solution for the critical section, that is Peterson's solution. The Peterson's solution is that, actually this is that software based solution for the critical section problem. So this is particularly limited to that two processes. So here what we do in this Peterson's solution means whatever the variables are initialized, we have to initialize those variables. Okay, first we have to initialize those variables. So now consider the two variables. The turn is a one variable. It indicates that which process wants to enter into that critical section. And we consider the another variable is flag. Now this is the code. With this, I'll explain how if one process is in the critical section. When one process in the critical section, the mutual exclusion means we should not allow the another process to enter into that critical section. So here consider the two processes, process 0 and process 1. I already said before we consider the processes, we have to initialize the two processes. So here the first takes that two processes flag of 0 and flag of 1. These two, the first we have to initialize with the false. Right? Now first consider that the process 0 wants to enter into this critical section. Now initialize the values I is equals to 0 and the j is equals to 1. Now the first flag of I is equals to true. So here flag of 0 is equals to true. Means we already initialized that flag of 0 is false, that is changed to true. Now the term is equals to j. So what is j? J is equals to 1. So here executing this condition while the flag of j means the flag of 1 is equals to flag of 1 is false and the turn is equals to j. What is j value here? The j is equals to 1. Turn is equals to j means, so here the j value is 1 means this condition is true. The false and true, the condition is false. So here when this condition is false, that particular process is enter into this critical section. Now if the process 0 is in the critical section, now that process 1 wants to enter into this critical section now. Now initialize the values, I is equals to 1 and j is equals to 0. Flag of 1 is equals to now true. Now this flag of 1 is equals to true and turn is equals to j. J value is 0. Now we are executing this condition while turn of j means j is 0. Sorry, flag of 0. What is flag of 0 is? Now the flag of 0 is true and turn is equals to j. What is j value is 0. So this condition is true. The true and true, the condition is true. When this condition is true means now the process is in busy waiting. Now coming back to this process 0, now after it comes out of from the critical section, it changes that flag of 0 from true to false. So that means now the flag of 0 is false. That means now this particular code can access that other process. Now see that again we will execute the same condition while flag of 0. What is now that flag of 0 is false and the turn is equals to j. This value is 0, this condition is true. That means the false and true means this condition is false. Now the process 2 can enter into the critical section. So this is the simple solution for the two processes. So if the one process is in the critical section, it should not allow that another process to enter into that critical section. This is about the Peterson solution.